Hello everyone, this one also about probability is about two-step experiments. So if an experiment it have two independent steps, the possible outcome can be listed in the table. So it due for experiment with two independent steps. Using table to list all the outcome. So revise the last lesson. We have that the probability of an event was equal number of successful outcome over total number of possible outcomes. And another one that we learned before, the probability of complement of A mean not A equal 1 take away the probability of A. So that is two formula that we have learned up to now. Let's do some example to see how we use the two-step experiment in probability. Firstly, a spinner with the number 1, 2, 3 is spun, and the card chosen at the random letter A, T, H, S. Written on 4 cards. Draw a table to lead the sample space. Alright, so before we lead the sample space in a long line look like this. However, we consist of two separate steps. So we need to create a table because the possible outcome is either combination of two independent steps. A, draw a table. So the spinner 1, 2, 3, and all the letters that we have A, T, H, S. So I will create a table that demonstrates all the possible outcome. So here you can have 1A, 1T, 1H, and 1S. The thing is 1A or A1, it doesn't matter, that is two independent steps. So which one appear first does not impact at all. 2A, 2T, 2H, 2S, and 3A, 3T, 3H, and 3S. So if you do the table in a different way, like A, T, H, S, and the spinner in here 1, 2, 3. Yes, it doesn't impact at all. Anyway, all good. So how many outcome that come to be? How many outcome does the experiment have? So for B, highly recommend you just count all the number of possible outcome in here. So whenever you do it, you can see that 1, 2, 3 here and 1, 2, 3, 4 here. So the total of possible outcome 3 times 4 equal 12 possible outcome. Now the next one, find the possibility of combination 2s that I said before. 2s and 2, it doesn't matter. So let I highlight where I have 2s. I have one here and nowhere else. So PR equal the number of successful outcomes. So I have 1 over possible outcome 12, 1 over 12. The next one, find the probability of an odd being spun and the letter has being chosen. Here we have two here, and number 1 and number 3. So we're having a look at number 1 and number 3 here. We're choosing both of them go with head, so I have 1 head and 3 head. So the simple space is 1 head, 3 heads. 2 heads is not odd, so it doesn't count. So the probability of this one 2 out of 12 equal 1 over 6. So that's how we solve the question. Let's move on to the next one. The school have 280 junior students, 320 senior students. Of 400 students who play sport and 240 students who do not play sport, I will create a table first. So junior here, senior here, play sport, and don't play sport. So here is the table that I have at the moment. And I will put extra column here for the total, because I don't know how many students are there in the school, including junior and senior. Alright, for junior, 280. So total of junior is 280. 320 senior, 320 senior here. 400 students who play sport here. They do not tell junior or senior, so 400 is supposed to be here. And 240 students not play sport is here, so I put it at So 240 students who are senior. Alright, so I have the number of students who play sport and who are senior, 240 here. So it is easily to find the number of junior who play sport. So the total, take away the senior, you have 400, take away 240 equal 160. Now, up to here, you have the number of junior who play sport. You need to find the number of junior who do not play sport. So 280, take away 160 equal 120. Now, you have the number of senior. You have how many students who play sport. So the one who do not play sport is 320, take away 240 equal 80. And just one more column to fill here is about total. 120 plus 80 equal 200. So the total in that column, 600. The total in that column also 600. So the good point to double check if you add all the number here is not the same as all the number here whenever you add it up. So it's definitely wrong somewhere. Alright, that is the table we have. Now, let's come to answer a few questions. I'm gonna write it very small on the side because we need the table. The probability of random junior student. Junior So they are junior. I do not care they play sport or not. So junior 280 over the whole population 600 people. Simplify 7 over 15. Now the next one, the probability of a student selected at random who plays sport. So play sport student. Again, they are junior, they are senior, it doesn't matter. I just only want the one who plays sport. 400 over the whole population, 600, simplify at 2 over 3. Now, this is the difference of junior student. The probability of junior student. Given that they play sport, remember, given playing sport. The thing is, some people gonna confuse between the number who play sport and the number who given that they who are junior given that they playing sport. So having a look at the one here, junior and play sport 160. The word given that here give you the population. Now the population is not 600 anymore. It's not the whole population. The population is the one who plays sport. Yes, 400. So 160 over 400 simplify at 205. I'm gonna compare it to another one. The probability of student junior who play sport is in here. Junior who plays sport in here 160. That everything they say. So we go for the whole population over 600, simplify at 4 over 15. So highly recommend you distinguish the difference between them. So given that give you the population that you care about. If they are not tell that, go for the whole population. Alright. Let's move on one more example before we finish the lesson. Alright. The letter is chosen from the word line and another is chosen from the word right. A. Draw a table, leave the symbol space. Again, I want a table with the word line here and the table with the word right here. Combine them together. With one horizontal, with one vertical, is not matter. Alright. So that one should be line. That one should be right. So create a table. Alright, it take a bit of time here. Alright, then second job, it combines them together. IL, RI, RN, RE, I, L, II, IN, IE, DL, DI, DN, DE, EL, EI, EN, EE. Alright, how many possible outcome? B. Possible outcome. As I said before, we care about all the possible outcome here inside the table. 1, 2, 3, 4 times 1, 2, 3, 4. 4 times 4 give you 16. I'm gonna change the color so it may a bit attractive for you. Now find the probability of R and R. So N chosen from line and R chosen from right. They clarify that N come from here and R come from here, and then R, it should be that one. I highlight it for purple color, and it's the only one that successful outcome that we see. So PR and R equal 1 out of all the possible outcome, 1 out of 16. Now B, probability of LD. Let's using another color. I'm using pink to highlight D, and I'm using pink to highlight LD as well. LD, DL, it doesn't matter. 1 over there. And no, none. So 1 over 16. Find the probability 2 vowel are chosen. Alright, 2 vowel, I delete them first. 2 vowel are chosen. 1 here, 2, 3, 4. Probability of vowel E4 out of 16. Simplify by dividing both numerator and denominator by 4. 1 of 4. F, find the probability that 2 consonants are chosen. Now let's count again. Someone say that miss, so the probability of 2 consonants is 1 take away the probability of vowel. No, because we have the combination of vowel, 1 vowel, 1 consonant, so it doesn't work that way. 2 consonant. Let's count again. 1, 2, 3, 4. No, not that one. 4. No small L. So 4 out of 16 equal 1 over 4. Now find the probability that 2 letters chosen are the same. Yeah, 2 letters chosen are the same. Let's have a look. I use a different color. Maybe circling by race. 2 letters are the same. I here. E here. We don't have RR, LL, DD. Alright, so I have 2 letter chosen. Sorry, chosen are the same. 2 out of 16 equal 1 out of 8. Yep, that's the last example of 2-step experiment. Thanks for watching.